In this BimlFlex webinar, we're going to be looking at dimensional modeling and the dimensional warehouse. Firstly, I'm just going to go briefly through dimensional modeling and the basics of that. I'm not going to do a deep dive in that. We're going to then look at our BimlFlex architecture, whether you want to go to the cloud or stay on premise and how you would configure those two. And then we're going to jump straight into BimlFlex demo where I will show you all of these options. So I've just taken this off Wikipedia, and these were the key things for me that stood out about dimensional modeling. The first one is obviously that it is intended to support end user querying, and it's based on this concepts of facts, which is your measures, and dimensions, which is the context of it. And then lastly, it is denormalized and optimized for querying. So it's a structure that is being created so that your end users can easily understand your data. It's not sort of like Data Vault or Third Normal Form where the data is structured to be optimally structured for data warehouse ingestion and saving of data. This is purely there for the end user in mind, and most of the querying tools or BI tools will, it works better with a dimensional model in place. So let's have a look at this from a BimlFlex automation point of view. So let me, the way BimlFlex works is you connect it to a data source. And these data sources could be files, it could be any other source that is supported, and or obviously database sources. What we do is we import the metadata from these source systems as best we can, and then we do a lot of metadata modeling and data mapping. We have the Data Vault Accelerator, which we're not going to discuss in this video, and you can apply additional business rules, which again we're not going to touch on in this video because it's just going to be a quick overview of the dimensional modeling. Now, all of the metadata and all of your coding is handled in our sort of BimlFlex metadata layer and your coding layer. From there, you can choose your delivery mechanism. In other words, you choose whether you want to go down and deliver to a cloud-based solution on the Azure cloud. The way this works is we will extract the data from whichever source system you have using, at the moment, we use SSIS. Or Microsoft SQL Server Integration Services to extract that data from the source system. We are currently working on Azure Data Factory version 2 support, and that'll hopefully be later in 2018. We will have that additional support to move the data into the blob storage. And from blob storage, we use Polybase and SQL code to load the data into either Azure SQL Data Warehouse and or a SQL Server database 2016 or 2017 sitting on a SQL virtual machine. At this current stage, while I'm doing the recording, Azure SQL Database does not support Polybase, hence that's not on here. But we could, if you wanted to go to Azure SQL Database, we could do this, but it follows a similar pattern down the bottom here, with the target just being in the cloud. So it'll use a staging database and it'll use this SSIS pattern or a ELT pattern to load the data. If you, however, want to build an on-premise solution, it goes down the following path here where we will stage the data. Optionally, you can switch on persistent staging on an operational data store layer. From there, we can either use SSIS and an ETL-based process to load your dimensional warehouse, or we can use ELT SQL. The SQL code that is used over here is very similar to the SQL code we are using at this Microsoft Cloud base. Obviously, there is some syntactical differences here between SQL Data Warehouse and SQL VM, but the code that goes through this layer here and this layer here is identical. The only difference, this pointing to an external table and this pointing to a staging table. From there, regardless of which option you choose, on-premise or the cloud, you can go out and you can build out your data mart or your dimensional data warehouse. These two things are pretty much the same pattern, but sometimes they are split out in separate things. And for this demonstration, I'm not going to be talking about Data Vault, but again, we support both the Data Vault. So whether you are on-premise or in the cloud or on-premise, the same code or same metadata mappings that you will use here, you can use to build out either one of these solutions. Now, the great thing about that is that you may be in a situation where you are currently building for an on-premise solution because you are having all of your servers are on-premise. However, you know that in the next 6, 9, 12 or 2 years, you may want to be migrating over to the cloud. Using BimlFlex make that easy because you can actually start developing your solution and simply with almost as literally as just flipping a switch, we can then port all of your code base across to a Azure SQL Cloud compatible deployment. So that's the BimlFlex automation framework. And I'm going to head straight into a BimlFlex demo and show you how simple it is to build a dimensional warehouse. Okay, so let me show you how we will be building a dimensional warehouse in BimlFlex. So what I'm using here is our Excel add-in that sits on top of our metadata database. And in our metadata database, we store all of the metadata, we track any changes to the metadata, and a full audit history of all the changes that you're making to your metadata. So what I've got in front of me here is I've got a clean or empty workspace, and I'm just going to go ahead and import our first metadata set. So when building a dimensional data warehouse, it tends to be built from a source to a dimensional warehouse. And what I mean by a source is the source could either be one of your source systems that you have denormalized some tables or created a query or view that denormalizes data, and that becomes the source of your dimension or your facts. Or you could have staged this data and then you've built a view on top of your staging layer, and you then go from that staging table into your dimensional data warehouse. Or you could have built a data vault with possibly a business data vault on top of it. And then what you could have done is you've built a view that represents your dimension or your facts on top of your data vault. In any way, is where I'm going to start with now is I'm starting with a view that has already been business logic applied and is ready for the dimensional warehouse. So I'm just going to go and import from the Wide World importers database here, which is the Microsoft sample database. And I'm just going to point to some views that I've already created. So at this stage, I've actually just put a view on top of the sample database just to simplify the process here. I import, it imports the table, and it also imports all of the columns associated with it. Now, the one thing that it wouldn't have done is because I'm using a view, I may not know what is the primary key from that view. So when you import views, the database doesn't know. So what I'm going to do here is I'm just going to set two things called the primary key and the business key, which in BimlFlex you need to have a business key, which is a concatenated. If you have multiple columns that makes up the business key or the primary key, you create a concatenated one, and that's covered in some of our other demonstrations here. All I'm going to do is I'm going to set current sheet here. So now I have my source. Right? I'm not going to do anything else to it. I could, if I wanted to, go and add additional attributes here, like an SQL expression. I could add any SQL expression on top of the data there. I could add exercise expressions here. If I wanted to derive additional columns in the flow, I could add additional derived columns in here. And I could also have, using a solve order, I can sort of stack them on top of each other. Now, I'm not going to cover any of that in this demonstration here. So I have the source for my dimension, and I want my dimension to look exactly like this. At this stage here, I can go in and change the things over here like geography. I can change location and stuff like that. But all I'm going to do now is I'm going to say, you know what, this dimension is exactly what I want. All I want to do, or this view is exactly the way I want my dimension to look. So I head over to the object here. I say, for this object, let me go and clone this table. And I'm going to put it into a target schema called dimension. And I want to create a target table of dimension.city. And the type I want to do is a dimension. So I can have a dimensional fact here. This is dimension. And I want to add an identity column. And the identity column that I want to add is called city key. So therefore I'm creating that surrogate key that you use in dimensions. I clone, it creates another object for me here. Let me go ahead and set that up. And then also what it would have done is it would have gone and created all of my target structure, including an identity column here, which is my primary key. It would have also gone ahead and done all of my source to target mappings. So now I know that I've got my source to target mappings here. All right, so now I'm going to go from my source to my target. That's all I needed to do. Now I've created my first dimension. I'm going to go ahead now and add the rest of the tables or the rest of the views and the rest of the dimension attributes into the spreadsheet, and then I'll go ahead and show you the output of that. All right, so I've gone ahead and I've actually gone and created imported the rest of the metadata here for all the other views that I've got. I've mapped them across dimensions and facts down the bottom here, and I've gone ahead and I've actually gone and created all of the dimensions and all of the facts, and down the bottom here I've got all of my source to target mapping sitting here for every single one of these. I've gone ahead and fixed up my metadata so that all of my source tables maps to either a fact or a dimension here. The one other thing that I have done here is if I go and look at a fact table here, I have gone and added my referential integrity here. So I've gone ahead and said, oh, on my fact table I have a city key, and that points to the dimension city with the city key there. So these references here will create my lookups to my dimensions, and will then have those additional attributes that creates all of the lookups and make sure that my surrogate keys are looked up. One other thing that we want to do possibly inside of here is we want the ability on a dimension to decide the change type. Now by default, when you clone the database, you'll see that they will all be type 1. You can, however, go ahead and set some of them, oops, that's not the right thing. You can go ahead and set some of them to type 2 and type 1. So what you can have here is you can have a dimension like this, which is customer, which are mixing or blending type 1 and type 2 attributes, which is commonly known as a type 6 dimension. You could also have a dimension here called city, which is all type 1. And then further down upon you could actually have a dimension here where all of the attributes is type 2, which is a pure type 2 dimension. So now what we then support is we support type 1, type 2, and type 6 dimensionality within BimlFlex. Now this functionality is the same whether you are deploying to an on-premise solution or to a cloud solution. So what I'm going to go ahead now is I'm going to go and build this out. So I'm going to head into Biml Studio and then import all of this metadata into our BimlFlex solution in Biml Studio, and then build it out and execute it. All right, so inside of Biml Studio, we have the BimlFlex ribbon at the bottom here. And if I hit refresh metadata, I've done this already, but I'll click the button again. If I have refresh metadata, it will actually pull all of the metadata from the database, bring it into BimlFlex, into Biml Studio, and now go and create all of the tables that I need to load into my data warehouse. All the table structures that is, to load in my data warehouse, and to create my staging database here. Now this looks a little bit differently. This looks slightly different when we're working in the Azure SQL Data Warehouse space, but I'll show that to you shortly. And what it would also have done is it would create all of my packages to extract all of my data from my source system, and then load my dimensions and my facts. BimlFlex is also clever enough to realize that based on your relationships between entities, so if the customer refers to the city, then it knows in which order they need to extract that data out of the source system and in which order it needs to load them into the data warehouse. So from this point of view here, we can actually go ahead and build out our solution. Now I have already prepared my data warehouse for this, so I've already gone ahead and deployed my SQL scripts. Now the SQL scripts can be deployed either manually by running these create table scripts here. So I can go and say create table scripts, which will give me a drop and create SQL statements here. So I'll just show you here real quick. This will create me all of my SQL statements that I need to go and create my tables. However, in BimlFlex, we also, when at build time, we can also build out a SQL Server Data Tools project, which means that you can build this out and then use either a DAC deployment or any other method where you can use a SQL Server Data Tools to deploy your database for incremental deployments. So we will also have additional videos later on that shows you how we do continuous integration and check that stuff in with source control. So for now, I'm just going to go ahead and actually build this code out and then open the packages and take you through those. All right, so the build is completed successfully here. Let's go ahead over to Visual Studio and let's just look at the output here. So this is the project that will do the source to staging extract. Remember, we're doing on-premise here, so the data is going to go from a source system, and it could be any source system, and we're going to land that into our staging database. These packages are fairly simple in the context that it's really just moving data from A to B. We recommend an approach where there is very little to no transformation happening in this layer here. So because we haven't switched on persistent staging for this source, it's a very simple process where we just truncate our staging table and then we just load our data from source to staging. There is some auditing happening in the middle here. We do some row counting, we add some audit columns, we add a couple of small things here, but effectively it just moves data from A to B. Now we can totally go and parameterize the source. You can add parameters to that. This could be change data capture enabled or change tracking enabled. So all of those kinds of how do we identify change is already covered in the BimlFlex framework and is covered in a source to staging video. From this, as you can see here, we have a batch. Now the batch could be multi-threaded, so you can decide how many threads you want. In other words, how many packages you want to execute. So I have just switched it on at 2. But as you can see here, because I haven't actually got any relationships between my views, it is just extracting everything here in one go. So you'll see one sequence container or pass one. If you were extracting from tables that actually had relationships between them, you would have multiple passes, and BimlFlex would actually decide in which order they need to extract the data. So let me go ahead and actually just execute this information, packages here, and then I'll go and show you the dimensional process. All right, so those packages executed now. What I have in my staging database here is, I'm just going to show you here that all I have here is I have some tables that I've extracted, and they've got some rows going in there. So here are just the staging tables. What we're going to do now is load this data from the staging database into our data warehouse using our data mart packages. So let's go ahead and open those up. So I'll just go and browse for those. And we'll open those up. So now we will have all of the packages. Now remember what when we did this, we had a couple of different things. We had type 1, just type 2, and then type 6, right? So the first one we do is just have a look at the batch first of all. So in the batch here, again, I have got 2 threads, but what you'll see now is I've got a pass 1, and then further down I have a pass 2, because there is dependencies where I can only load the fact sale table after I've loaded, let's just say, these dimensions. So I can only start loading the facts because they reference a dimension. So that's all figured out for you by purely the dimension keys. Now let's go and have a look at just a straight type 1 dimension, which is the city dimension here. This will have, again, this will have some logic in there, but the key one here is this data flow task here. And data flow task here, again, we do some housekeeping. We do create a hash of the type 1 attributes. We look up, we look up if it exists, and then we come down here and we just insert if it doesn't exist. And if there's changes, we go into a type 1 pattern. We load that into a staging table, and then we actually just merge that data. So the merge statement will know whether it's a type 1 or type 2 change. Let's go ahead and look at, I think the employee was just type 2. So let's look at the employee package now. And again, it'll be pretty much the same. The only difference in these packages will be around the sort of control flow down the bottom here. So those will all be the same. We'll do something slightly different. But here we will go ahead and do some type 1 and type 2 changes here. So it'll identify whether there's any type 2 changes or type 1 changes, and it'll pass it through these sort of processes here. And I think the customer one is similar. So as you can see there, BimlFlex is already configured to handle type 1 and type 2 automatically, and all you need to do is go into your columns and define whether it's type 1 and type 2. So again, I'm just going to go ahead and actually run these ETL packages and just show you the data at the output there. Okay, so those packages have now completed running. So let me have a look here at my data warehouse here, my dimensional data warehouse here. Look at the tables here. And again, as you can see, here's my facts. We've chosen in this case to stage inside of the data warehouse. So you can either stage your, when I say stages, we basically look at what has changed. We put the changes into a staging table, and then we use a SQL merge to merge the data. This staging tables here could be in their own separate database, or they could be in the same database. Those are configurable options. But as you can see here, I've loaded my facts, my dimensions here. It's all loaded, which takes care of your on-premise solution. So now to go ahead and actually do the Azure Cloud one, and let me go and show you what you need to do to either move your data into the cloud. All right, so let's set up Azure SQL Data Warehouse here. So the metadata that I'm working with now is exactly the same metadata that I just used for my on-premise solution. The only changes that I need to make, now this is obviously if you haven't gone in and made a number of SSIS expressions, right? So if you created a whole a lot of derived columns using SSIS expressions, obviously you would need to port that code over into SQL compatible code, right? But all you need to do is, if you have your metadata, regardless of whether you're targeting which system you're targeting, all you need to do to rebuild your code for a different target platform, in this case it'll be Azure SQL Data Warehouse, is I've just dropped in my Azure SQL Data Warehouse data source in here, my connection string in here. The database that I'm connecting to is BimlFlex Data Warehouse, and then only thing I need to do here is go ahead here and change this from an OLADB, which will use SSIS, to OLADB SQL based ELT, and again this one here. So I'm just creating my staging database, and my data warehouse to SQL Data Warehouse. Now, if you were using a SQL VM, again, you would actually point this to Azure Blob Storage. So this would actually become Azure Blob Storage rather than SQL Server, right? But in this case, I'm just going to go, because the Azure Blob Storage is inferred. In this case, I'm going to SQL Data Warehouse. Over here, I'm actually going to say I'm going to use Azure SQL Data Warehouse, and Azure SQL Data Warehouse here. And that's it. Those are the changes that I had to make to move my metadata and say, don't target my on-premise solution, now target my Azure SQL Data Warehouse solution. I will say set current sheet here. I'll go ahead, there's a couple of other settings. At the top of our settings tab here, we have some storage accounts and stuff. Don't worry too much about this. You can set these, but these are all parameterized in your SSIS project. So when we actually move the data from your source, any supported source, into Azure Blob Storage, we use these settings here. If you don't want to put those settings in, that's fine. These settings are also parameterized in your project. Therefore, you can actually set them in environment variables, or you can set them via an environment. Okay, but for now, those are the only changes that I had to make this solution now going to go to the cloud. So let me go ahead now and again using Biml Studio, and then now just refresh my metadata, pointing to this solution, this metadata, and show you the difference in the project. All right, so let me go ahead and just refresh the metadata here, and pull in the data warehouse version of the code now. What you'll see here is that what we have here is a whole couple of connections here to blob files. So what we will do is we'll extract the data from the source and put that data into a flat file that is going to be compatible for Azure Blob Storage and Azure SQL Data Warehouse. When you're working with a large data set, you want to split the data into as many parallel files as you possibly can, depending on how many data readers your Azure SQL Data Warehouse allows you. And that will depend on how much you've scaled it up. As you can see here at the moment, I have got one file for every source. But let me go ahead here and just configure it to be 2 files, or 4 files for every source. The way I would do that is I would go into BimlFlex again, and on the source that I'm relevant to, I'm going to say I want to extract 4 files. So I want to go and thread this across 4 files. So I want to have 4 files for every single table. However, I can also go into my larger file. So let's just say my sales table, I know is my largest table. I may want to go ahead and actually say to this one, I want to go and put you across 8 files. Okay. And you can have it toggle these selectively. So, you know, if you have files that are really, really large, you can make them bigger, and ones that are just average, you can make them smaller. So I'll go ahead now again and refresh the metadata here. And what you'll see now is you'll see that these files will change to, every single one will have 4 files. The custom one will have 4 files, over and down, and then we get down to the sale here, and this one now has 8 files. So what will happen is when I build out my packages here, it'll be 8 files across. So that is just my blob files here. We will also now still have our data warehouse tables that will be created on Azure SQL Data Warehouse. This will be Azure SQL Data Warehouse compatible files. And then we will have our external tables. So these will be with Azure Blob Storage and Azure SQL Data Warehouse, you need external tables to create that. And then obviously we will have our packages to load from source into blob storage, and then we'll have a batch that will call all the stored procedures. So the first thing I'm going to do here is I'm just going to go ahead and build this out and then run the source to blob storage packages so I can get the files up into blob storage, and then I'll take you through the rest of the template. So let me go ahead and just build this code out here. Alright, so the build is completed here, and I will now go ahead and just show you the packages here. So first one, I'll just open up the city one here, and what you'll see here, apart from a couple of things here like extracting the data here from a source, and again this will be whether you're using change data capture, parameter driven queries or change tracking or anything like that, you'll see here it'll extract the data, and because I set 4 threads, it'll push it into 4 different files. If I look at the sale one, it's the same pattern here. It'll actually push it across and drop it into 8 files instead of 4. So as you can see here, it's going to drop it into 8 files. The next thing we're going to do, and again some of the stuff is configurable, but it'll actually go and grab that file depending on whether you've decided to compress the file at source or whether you want to push the uncompressed file up. It'll convert the file to UTF-8, which is which you need to be compatible or compliant with with Polybase. It'll convert it to UTF-8 and then it'll zip it all up. Using AZ copy, we'll copy the files across to blob storage and then get rid of the file because the file already exists in the blob storage. So I'm going to go ahead now and just run this ETL packages. The one other thing to note is that this little bit over here will actually also check whether the file is empty. So you could have a small data set that you want to split across 8 files, and possibly because there may only be 2 or 3 of those files may actually have data, the other files may actually have 0 bytes or be empty. Now Polybase have a bit of a problem when you actually load up empty files into blob storage and try and run it in Polybase. So this process over here will also look if the file is empty and will only move files with data up to Azure Blob Storage. So let me go ahead and execute this. Once I've finished executing this, here is a staging blob container that I'm going to use. All of the files will now go and sit into this blob container, and I will then be able to run the Polybase side of things or the Azure SQL Data Warehouse side of things to actually load that data up. Let me go ahead and just execute this package. Alright, so now I have gone ahead and run the SIS packages, and it's actually loaded up all of the files up to Azure Blob Storage. As you can see here, if I look at the sales one here, there's a good couple of files there. If you go back here and just look at the city one, you'll see there's 4 files there, and so forth, right? So as you can see here, it would have gone and loaded up all of the files. So now that I have all of the files in blob storage, I now need to go ahead and also create the external table scripts. Now with inside of BimlFlex, we obviously, if we're targeting Azure SQL Data Warehouse, we create the external table scripts files over here. We access it by going to generate script Polybase external tables, and again, as I said, we will also output this into SQL files in the SQL Server Data Tools project. However, at this current stage, SQL Server Data Tools projects don't support Azure SQL Data Warehouse, so you might need to go and use additional tools to deploy your code. But if we click Polybase external table script, we'll get this script output here at the back here. And what you'll see here is there's a placeholder for an extension board called external file format targeting this WWI. What that means is with an external table, you need an additional file format to say that this is the file format of the files that we're going to go ahead. So let me go and actually just go and add that external file format here by going up to Polybase here, hitting external file format. I get a sample set here, and this is kind of pre-created for you, and all you need to do is just grab that target there and pop it in here, right there. And now what will happen is if I just right click here and refresh these table scripts here and regenerate at the Polybase, I will now get the external table file formats there. And again, we've prepared this, we've set everything up already. So if I now go ahead and just go and run this script again, Polybase external table script, what I will get is I will actually get the same script, but I will now have the external table file formats added to it, and now I can go and create these table scripts ahead. So let me copy all of this and then go ahead and connect to our Azure SQL Data Warehouse and deploy the code. Alright, so I've gone ahead and connected to our Azure SQL Data Warehouse here, and I've deployed all the external tables, and I've also deployed all the dimensions and facts here. The stage schema is tables that's held over from a previous demo, so we can ignore them for the purpose of this presentation. And now all I need to do is actually go and create the SQL code to load the project and the batch file that we'll call the stored procedures. So again, I just go in here and I say, give me all of the data mart stored procedure scripts that I'll need to actually run and build my SQL data warehouse. I'll grab all of that. And again, I'll just go over and I deploy this. Now, I'm doing all of this manually, but you can totally automate this. Again, when it comes to Azure SQL Data Warehouse, there are some formats there that are not quite ready yet for or continuous deployment, but that is sort of more a problem with the Microsoft SQL Server Data Tools project at the moment. So let's go ahead here and just create all of the packages. All of the stored procedures. So now I will also have in here I'll have all the programmability, which has all of the stored procedures to load my data mart. You'll also see here that I've got some additional ones here, which is our data vault stuff with this RDV over here. But the ones that we're going to need to load is these guys over here. It's going to be using to load our data mart. The next thing we need to do is just build the project again. And this will now build out an additional batch file that will SSIS package that you can deploy to an Azure SQL VM. But you can also call those stored procedures using using Azure Data Factory if you want. But what we do is we build out an SSIS project SSIS project that has a single file SSIS package that just calls all of these stored procedures in the right order. Alright, so the build is completed, and as you can see here, we've got a single package here, a project with a single batch file here, and inside of this batch file, this will simply call all of those stored procedures in the right order, and obviously this will be in as many sequences as you want. The reason why these are in their own sequence containers is because you could have additional sort of pre and post processes that you can add to any one of this. What I mean by that is, let's just say we're loading the fact sales, and after we've loaded this, we wanted to go and process some additional logic. That's just why it's in a sequence container, because we can add some custom extension points in here. But effectively, this will call it, and we'll go and load all the data in the right format. So I'll go ahead here and just configure the project settings here, just configure the configuration settings, and point this to the Azure SQL Data Warehouse, and then I'll execute this batch file, and I'll show you the results. Alright, so once the package is executed, you will have now got all of your data exactly in the same way inside of your data warehouse here, Azure SQL Data Warehouse. There are a number of other factors that you need to take in consideration when you're building Azure SQL Data Warehouse. The fact that Polybase handles decimals and integers, nulls, by replacing them with zeros, or depending on how you've set up your external file format, decimals, that is nulls, could actually have your loads fails. We do handle quite a bit of that with data type mappings in BimlFlex, but that is a little bit more of an advanced subject matter, and we're not going to have time to cover it all of today. But just be aware of that. With BimlFlex, you actually will have the capabilities to make adjustments for all of that kind of stuff there. So hopefully this has given you a great overview of the BimlFlex functionality with dimensional data warehousing. Regardless of whether you are building an on-premise solution or a cloud solution, you will be able to take your data from a source system, whether that is a staging layer, data vault, or straight from a source with a denormalized query or view, and move that data into a data mart, a dimensional data warehouse, and be able to apply your type 1, your type 2, and your type 6 mappings if you want. Thank you for watching, and I hope to see you in the next session.